So let's talk about another class of integrals where the integral involves an inverse trig function. And once again, let's start in the forward direction. Let's recall the derivatives of the inverse trig functions, and let's see what happens. Now, all the way back in Calc 1, you found that the derivative of inverse sine of x divided by a constant could be found by taking 1 over the square root of the constant squared minus x squared. And the derivative of inverse tangent of x over a constant could be found by taking that constant, dividing it by constant squared plus x squared. There's a 1 here. So then let's use these ideas to find the most general antiderivative of the following functions. Here, let's find the antiderivative of 1 over 9 minus x squared. Now, I think the key here is to acknowledge the fact that 9 is 3 squared. So this function that we're trying to integrate has exactly the same format as this derivative of arcsine of x over a, where a is equal to 3. Therefore, I will put as my answer that the antiderivative is sine inverse of x over a equals 3. Now take a moment. Is this actually the correct answer for this problem? And the answer is no, and of course what is missing here is the plus c to indicate that this is not just my favorite antiderivative, this is a description of all possible antiderivatives. Don't forget that plus c. Okay, now let's scroll down here and let's try and find the antiderivative of 1 over 16 plus x squared. Now 16 being 4 squared, and this fraction having a plus sign in the denominator and no square root, this feels a lot like it should have to do with inverse tangent, because inverse tangent also had in the denominator number squared plus x squared. However, in the derivative of arctan, we saw an a in the numerator. In our case, it would have to be a 4 in the numerator. However, our function has a 1 in the numerator. So what are we going to do? Well, we are going to alter this function and artificially place a 4 in the numerator. But we have to do this in such a way that we're dealing with the same function that we started with. So if I'm going to place a 4 in the numerator, I also have to counter that with a 4 in the denominator. So I'll put a 4 in the numerator and 1/4 in the denominator. Now, constant multiple rule says that you can essentially ignore the 1/4 and take the derivative of just this 4 over 16 plus x squared. And this matches our arctan format exactly. So this will be arctan of x over a equals 4. And once again, don't forget, plus any constant, plus any constant.